Hey guys!
And gals.
Today we will have a look at a few quantizers and the differences between them, and I want to thank my patrons first of all for their support, but also for the idea for this video. And we will start with a couple of simple quantizers, and I don't mean simple in a negative way, but it's just that they are easy to use and are quite intuitive. So the first one will be the relatively new quantizer from VCV, which will look like this. You can see it's pretty small, and it has one input and one output. Now I have here the Turing machine, which will provide the pitch information for today. I also have a few oscillators. One of them is basal, which is also polyphonic, so we can use also polyphony when available. And we have also some reverb here from plateau, just so it's not so boring. So let's go back to the VCV quantizer. Let's send the main CV output of the Turing machine to the quantizer. Let's also send this to basal and have a listen. I will gate for now a slap from the clock. Very nice. So we have a sequence, and at the moment it's being quantized to a chromatic scale. So a scale with all 12 semitones. And of course we can turn off a few notes, and we will start from up. So this is how it works on this quantizer, and we will work our way down. So let's say a C major scale. So this will be C, then C sharp we don't need, then D, D sharp again, not in the scale, E, F, F sharp we can take out, G, G sharp we can take out, A, B flat or A sharp we don't need, and then we have B. So we have now the C major scale. Very nice. So you can see how easy it is, how simple this is. One input, one output, and we have a quantized signal. Now this quantizer is also polyphonic, so I have here the merge module to merge a few signals into a polyphonic signal. So let's send also the volts expander, and now we have a polyphonic signal. You can see it also on the quantizer. Very nice. So this was the first quantizer. And now let's move on to the quantizer from JW. This is again a very simple quantizer, just plug and play. But here we can choose the exact scale and key we want. So let's say we want G. Let's go with chromatic again we have, and we can also choose none, but let's go with Lydian for example. So let's make the connections and listen to this. So now we have G Lydian, and we can also control this with voltage and modulate it. And also this is a polyphonic quantizer. Very nice. So you see, quite easy to use. Okay, the next one is the quantizer from the XOR. This one here, which is also quite simple but has a couple of nice outputs. So let's make the connections like this. And also here we can choose the scale. So now it's on chromatic, and here we have a few more scales to choose from. Let's go with harmonic minor for example, and let's go with D. So now we have D harmonic minor. Now we also have another two more outputs. One of them is the octave output, which will output only the octaves. So let's send this to the FM operator for example. So you can hear we have just the octaves. And we have also a semitone output, which will output the quantized signal, but only in a range of 1 octave, regardless of the range of the signal. So let's send this to Blick. So we have the quantized signal, and never mind what range we have. So here I have the scale all the way up on the Turing machine, and still we have the same range of pitch. while the other outputs will be transposed. Now those two outputs, let me just turn this down for a second. Those two outputs, the octave and the semitones, will only work if the main output is connected. So if I take this now out, they will not work anymore. We have to connect the main output. And also this quantizer is polyphonic, so let's bring back just Basil, sorry. Let's make the connection to a polyphonic signal. So also this quantizer is polyphonic. Very nice. The next quantizer is Quantum from ML. Now, Quantum is one of my favorite quantizers in VCV, and it has some really nice features. So let's make the connection and listen to this. So first of all, let's enter a scale, and you can see that we have here sort of piano keys, so we can see the notes. So let's go with the C, D, E flat, F, G, A flat, B flat. We have a C minor scale. And in the right click menu, we can choose the quantization mode or the quantizer mode, left, up, down, how it will, the signal will be quantized. We can also transpose the scale, and this will only transpose the scale and not the notes. So I have here the dual attenuator, which will output just a constant voltage, just an offset. So you can see we are transposing, and it will not transpose the pitch, so I can go as high as I want. The pitch will stay the same, it will just transpose the scale. Very nice. Now Quantum is also a gate and trigger outputs, this we don't need anymore, that will fire out a signal or a gate or a trigger with change in notes. So let's take the gate, the clock out of the gate of SLEP, and let's use the gate from Quantum. So now we get a gate only with change of notes. Now another really nice feature is the note and toggle inputs, which allows us to modulate the scale. So let's duplicate Quantum. Let's send the volts expander of the Turing machine through Quantum, through the first or the second Quantum, to the note input of the other Quantum. This will tell Quantum which notes to turn on and off. And we have here the notes we want selected. And by sending a trigger to the toggle input, we can tell Quantum when to turn them on and off. So we'll just use the trigger output of the first Quantum. And you can see that we have modulation here. The scale is being modulated. And again, because we are using another quantizer, we can turn on and off notes of a specific scale, and in this case it's C minor. And also Quantum is polyphonic, so let's use two different signals. Oh yeah. And I made actually a whole video about Quantum, so if you find it interesting, there will be a link in the description to this video. And if we are already dealing with Quantum, let's remove this for a second. We can also check out Quantum Multiverse. Let's put it here, which is a bit bigger as you can see, but that's because it's 8 quantums in one module, and it has 2 additional interesting features. So let's again set a scale. I will just choose 4 notes in this case. Let's send the main output of the Turing machine to the first row or the first section of Quantum Multiverse. From there, let's go to Basil, and we will use also the gate output. You can see we have 8 rows, which means 8 quantum modules. And the first feature is that we can save up to 8 different scales or presets and trigger them to load. So now I have here C, E flat, G, B flat. Let's save this by clicking the right button here. And now we can change this. Let's go with D, F, A, and B flat. Now I can save this to the second row. And now by using a trigger or by clicking the buttons, I can load. You can see it here. I can load the scales and create whole chord progressions. And another really cool feature is the spread feature, which will spread the different unconnected inputs. And let's see what I mean. So we have we have more rows here and nothing is connected to the rows, or let's concentrate on the second row now, but it is normalized to the one before it. So if we send it, just the output, to the FM operator, for example, let's also use the gate. So we have the same sequence but a bit spread from the original, and we can change this even more with the spread amount, so we can take it down or take it up, and we can create whole harmonies from one sequence. Now I should mention that this is a commercial module, but as you can see it can come quite handy, and it's full with creativity. Very nice. So let's move on to the next quantizer. And this quantizer is quite similar to Quantum. It's called Rewin from Repelzen, which is a 4-channel quantizer, and each channel has also an octave control. So let's use the first channel for now. I will use the gates from the clock. Very nice. Let's set a scale. You see, when we have nothing connected, nothing selected, we have a chromatic scale, but let's enter a few notes. Now let's send this also 2 more rows. Let's send one to the FM operator and one to Blick. Let's put them back here so we can see what's going on. And I will use again the gate from the clock. So you can already see that the outputs are normalized, but we can change the octaves for each one. So let's take this one lower and let's take this 2 lower, let's say. Oh yeah. Also this quantizer we can transpose, and this will actually transpose the pitch through the root input. So the higher I go, the higher the pitch goes also. Or the other way. But we have here a really nice feature. We have here scenes that we can choose. Again, it will be like presets that we can save scales and move between them. So let's say here we have C. Let's do this again with D. So now scene 1 will be this chord, scene 2 will be this chord, and of course we can also modulate this or automate this with an external signal. Also here in the right click menu we can change the quantization mode up, down or nearest, and we can also load and save scales, which is also quite handy. Now you can see that unlike on Quantum we have no trigger or gate outputs, but there is another module from Repelzen called Retrig, and it will work together with Rewin and send triggers upon change in note. So what we have to do, send the same pitch information to Retrig, and from there we can go to the oscillators or to the envelopes. Very nice. Okay. The next one is quite similar to Rewin. Let's delete this. It's called Lazy Susan from the Holonic Systems collection. Also here we have 4 channels, so let's connect the first channel, and for now I will use the clock again as gates. Very nice. We have built-in scales, which are all the different modes. You can see we can just move between them. But of course we can also change, take out and bring in notes we want. We can also automate or modulate this. So again we can create whole chord progressions. Also here we can transpose the scale, and this will also here transpose the pitch. Now a really nice feature of this quantizer is first of all the built-in CV attenuator, so we can attenuate the signal. So if I take the scale all the way up on the Turing machine, I can attenuate it from here. So if you are using something like sample and hold, you can attenuate from the quantizer itself, which is again quite handy. And we have also trigger outputs we can use. So let's do this. Again, they will fire a trigger upon change in notes. Now those are triggers, so you have to make sure that your envelope is set accordingly. And another really nice feature are the trigger inputs that will act as a sample and hold, triggering the sample and hold. So let's say I will take a trigger from the Turing machine. You see? We have sort of sample and hold built in this quantizer, and we have 4 of them, of course. Very nice. So the next quantizer will be from nysthi. It's called the Scala Quantizer. Already you can understand that this quantizer is polyphonic, and it has also additional inputs and outputs, 11 more inputs and outputs. They are not polyphonic, only the main input is polyphonic. So let's make this connection, input and output. Again, I will use the clock as a gate. Now in the right click menu we can choose a scale, and we have a few to choose from. Let's go with something weird like ancient Greek diatonic scale something. We can also load Scala files, add new Scala file, so you can add your own scales. Now because of this, because we can use Scala files, it will also quantize to quarter tones, quarter notes, quarter tones, and you can have also micro tuning. We can also change and modulate the octaves and the tuning. Very nice. And again, it's polyphonic, so we can make this also like this. Nice and weird. Now there's another option here, the MIDI note map mode, which I'm not so sure what it's for, but if you need it, it's there for you, and please let me know in the comments when and why to use this. Very nice. So this was this quantizer. Now, if you are already dealing with Scala files, we have also a Scalar or Scalar from VCV. This is a commercial module, an official commercial module from VCV. It has also 4 channels. Let's use already one of them, like this. You can also have here different notes in each scale, in each octave, sorry. So the first octave, let's turn off some notes by clicking and holding Control and clicking the notes. I can turn them off. So I can have for each octave different notes. Or I can have the same notes on all octaves by changing this octaves mode from variable to shared. Also here we can load Scala files, you can import them and export them, you can enable all notes and disable all notes. We can transpose the pitch and the scale. We can add also error and imperfection to the quantization by lowering the depth amount and the tracking accuracy. Adding warp will add error to the quantization. Now this quantizer will not quantize downwards, so it will not go below the pitch we set on the oscillator, so just keep this in mind. And again, we have 4 channels, so we can use do something like this. And also about this quantizer, I made a video. I will put a link in the description to this video if you're interested. Now, the next quantizer. Those are a lot of quantizers we have. We have the scale quantizer from Amalgamated Harmonics. This one has 8 inputs actually. So let's choose the first one. And I will use again the clock for now, the clock from the Turing machine. We can change the key. So let's go with F and the scale. Let's go with Mixolydian, for example. And again, we can use the trigger outputs. Of course, we can also modulate the key and the scale. We can also transpose the pitch by semitones. And also here we have the sample and hold feature. So let's use this. Oh yeah, nice. And here we also have octave knobs or dedicated octave knobs for each channel. So let's use another channel here for the FM operator, and the output is here. Let's also use the trigger output. And also the hold feature, the sample and hold feature. We can change the octaves again. Oh yeah. And also this quantizer is polyphonic. So let's do this something like this, for example. Oh yeah. Very nice. The next quantizer is the scalar or the Customscaler from Noobhour. Now here we have 5 octaves we can set, so we can have different notes again on each octave. So let's do something like this. The low one will be C, then we will have D. Let's have something like this, and here we will have E, and F we will have here, and G on those two. So you can see I can have on each octave different notes, and A and C. Let's do something like this, and let's connect it already. Okay, very nice. Take this up a bit. I can transpose it by semitones. And also here we have something similar to the note and toggle function on Quantum, so we can turn on and off different notes. So let's add this time the quantizer from JW. Let's set it to the same scale we have here, C major, so let's go with C major. We will use the volts expander through the quantizer to the volt per octave input of this quantizer of the Customscaler. This will decide again which notes to turn on and off, and a trigger to the toggle input will decide when to do this. So let's do this with a clock. You can see where they have this modulated here. Very nice. Now we can also randomly, let's take this out for a second, we can also randomly deactivate the existing nodes, not delete them, but just deactivate them. So let's do something like this. We will trigger the random function. Again, let's do this with our clock. And you can see they are being deactivated and activated again, and we can change the probability all the way to the left. All will be deactivated, all the way to the right, all will be active. And we can change the probability. This is a really nice feature. And also this module is polyphonic, so we can use also polyphony. This we don't need. Very nice. Now we have another quantizer, and if we are dealing already with the probability, it's called the probably note. This is a really nice name, from Frozen Wasteland. So let's connect this, and this quantizer will need also a trigger. So it has already a built-in sample and hold. So let's use the trigger also for the gate. Very nice. Now this quantizer is all about probability, and we can choose a key and a scale. So let's go with E, not chromatic, but let's go with minor, Aeolian. We can change the probability setting for each note, and you can see the light is going dimmer or brighter. We can also do this globally with the focus knob. And we can have also the spread knob that we can also allow other notes in. You can see this. Now this is a really interesting quantizer. It's pretty new. So I think what I will do, I will let you explore it even further and send me your results, please. But I think that was enough for now. Many quantizers we have to choose from. Each one of them is special in its own way. Again, thank you Patreons for your support, and thank you for the idea for this video. I hope you enjoyed it. If you did, please hit the like button. If you enjoy what I do, consider becoming a Patreon. If you want to see more videos like this, please subscribe and hit the bell. And have a good one.